Have you ever wondered about the strange, fascinating world that lies beyond what our eyes can see? Welcome to the enigmatic sphere of quantum physics, a realm that underpins the very fabric of our reality, yet remains elusive to our everyday perception. This isn't a fantastical journey into a sci-fi narrative, but rather it's a deep dive into the heart of our universe, into the microcosmic realm where the rules of the game change drastically. Quantum physics at its core is our best attempt to understand the behavior of particles at the smallest scales of the universe. It's not just about tiny particles, though. It's about the very nature of reality itself. You see, quantum physics is a departure from classical physics, the physics we're all familiar with, the physics of apples falling from trees and planets orbiting the sun. In the quantum realm, things start to get a bit, well, quirky. Particles can exist in multiple states at once, thanks to a phenomenon known as superposition. Imagine flipping a coin. In our macroscopic world, it lands either heads or tails. But in the quantum world, it's as if the coin is both heads and tails at the same time, until you look at it. Sounds crazy, right? But that's the quantum world for you. Then there's quantum entanglement, another mind bender. Two particles can be entwined in such a way that the state of one instantaneously affects the state of the other, no matter how far apart they are. This has been dubbed spooky action at a distance by some of the greatest minds in physics, and it's still a hot topic of research and debate today. So, why is quantum physics important? Well, without it, we wouldn't have much of the technology we rely on today, from lasers to MRI scanners, even our computers. It's also the key to unlocking future technologies like quantum computing and quantum encryption. So, the world of the tiny, it appears, plays by a different set of rules. Strap in, because we're just getting started on this quantum roller coaster. Up next, we'll delve deeper into the principle of superposition and the curious tale of a certain feline friend. Stay tuned. Imagine a cat that is both alive and dead at the same time. Sounds bizarre, doesn't it? To understand this, we need to delve into the strange world of quantum mechanics and the principle of superposition. The principle of superposition, in layman's terms, means that a quantum particle can exist in multiple states at the same time. It's like being in two places at once, or in our case, a cat being both alive and dead simultaneously. This concept, while unsettling, is a cornerstone of quantum physics. To illustrate this, let's use the famous Schrödinger's cat thought experiment. Here's how it goes. A cat is placed in a sealed box with a radioactive source, a Geiger counter, and a vial of poison. If the radioactive source decays, it triggers the Geiger counter, which then breaks the vial, releasing the poison and killing the cat. According to classical physics, the cat is either alive or dead, based on whether the radioactive source has decayed. Simple, right? But quantum mechanics, with its superposition principle, tells a different tale. In the quantum world, the radioactive source is both decayed and not decayed until it's observed or measured. In turn, the cat is both alive and dead until we open the box to check. Only when we observe does the superposition collapse into one state or the other, alive or dead. This doesn't mean the cat is in some ghostly half-life, half-death state. Instead, it's about probabilities. Until we observe, there's a certain probability the cat is alive, and a certain probability it's dead. It's only when we check that the odds resolve to a definite outcome. This might sound like something out of a science fiction novel, but it's a fundamental part of how our universe works at its most basic level. It's the principle that underpins the weird and wonderful world of quantum physics. Schrödinger's cat then beautifully illustrates the bewildering principle of superposition in quantum physics. What if I told you that two particles, no matter how far apart, can affect each other instantaneously? Now that might sound like something straight out of a sci-fi movie, but it's actually a fundamental concept in quantum physics, known as quantum entanglement. Imagine you have a pair of dice. Under normal circumstances, when you roll them, the outcome on each die is independent of the other. But what if the dice were quantumly entangled? Well, in that case, the roll of one die would instantly determine the outcome on the other, no matter how far apart they are. Spooky, isn't it? This is essentially what happens in quantum entanglement. So how does this happen? Quantum entanglement occurs when particles become inextricably linked, and the state of one can instantly affect the state of the other. This can happen when two particles are created at the same point and instant in space, such as during a subatomic particle collision. Once these particles are entangled, a change to the state of one particle will result in an instantaneous change to the state of the other, regardless of the distance between them. This happens faster than the speed of light, defying our conventional understanding of the universe. Einstein, puzzled by this phenomenon, famously referred to it as spooky action at a distance. Despite his initial reservations, numerous experiments over the years have confirmed the reality of quantum entanglement, making it a cornerstone of quantum mechanics. However, don't pack your bags for teleportation just yet. While quantum entanglement is indeed spooky and fascinating, it doesn't mean we can instantly send information or matter across vast distances. The reasons for this involve the intricacies of quantum measurement and the no-cloning theorem, which are topics for another day. Quantum entanglement, thus, introduces us to the spooky yet incredibly fascinating aspects of quantum physics. So, the next time you roll a pair of dice, just think. In the quantum world, those dice could be entangled, playing out a cosmic dance of chance and certainty. The weird world of quantum physics might seem far removed from our daily lives, but is it really? If we take a closer look, we'll find that it's integral to many technologies we use every day. The lasers in our DVD players, the semiconductors in our smartphones, the transistors in our computers, all owe their workings to the principles of quantum physics. It doesn't stop there. It's also the driving force behind many burgeoning technologies that promise to revolutionize our future. Quantum computing, for instance, has the potential to solve problems that would take our best supercomputers millions of years in mere seconds. It's the quantum world's superposition and entanglement principles that make this possible. The science that once seemed surreal and distant is now at the heart of our technological evolution, pushing the boundaries of what's possible. Indeed, the baffling yet beautiful world of quantum physics is not just about understanding the universe, but also about shaping our future.